Today we're going to focus on the theorems in section 10.1. The first theorem says that if a line is tangent to a circle, so we know with lines that are tangent to a circle, they will intersect the circle at just the one point. Then we're going to know that it's going to be perpendicular to the radius that is drawn to that point of tangency. So if you notice the radius shares a point with a line that is tangent, then we know that this will be a perpendicular that we can draw in there. So we could go ahead and state that as if line M, is tangent to circle Q, then we know that line M is going to be perpendicular to PQ, to that segment, to that radius. Okay, the next theorem talks about in a plane, if a line is perpendicular to a radius. So if in the same plane you have a line that we know is perpendicular to a radius at its endpoint on the circle, then we know that that line is going to be tangent to a circle. Kind of almost sounds like the converse of our previous theorem, where we're saying that now if you know that you've got a perpendicular measure here, we have a radius and we have a line that shares that common endpoint of the radius, and that line is perpendicular to that radius, then we know that that line will be a tangent line. So here we could say that if line M is perpendicular to QP, then we know that line M is a tangent to circle Q. Alright, the last theorem is talking about if we have two segments from the same exterior point. So we have two segments here that are connecting at that same exterior point, a point outside of the circle. And we know that they are both tangent to a circle. So they're both intersecting a circle at just one point. Then these two lines will be congruent. These two segments, I should say, would be congruent. So we could say that if we know that RS and ST are both tangents to circle P, then we know that RS is congruent to TS. Okay, and those are the three theorems that we wanted to focus on today.